Today I came with a next video of module 3. Hope you all see the last video, that is the introduction of Laplace transform and inverse Laplace transform. Review of Laplace transform. Here I deals with some problems by using Laplace transform and inverse Laplace transform. Some simple problems in Laplace transform. First one is f of t is equal to 1. So that is Laplace of 1 is equal to f of s, that is given as this is the equation for Laplace transform. So that is integral 0 to infinity e raised to minus st dt is equal to limit a tends to infinity and the integral changing to integral 0 to a, and the limit is changing, infinity is changing to a, and e raised to minus st. Here our function is 1, so e raised to minus st into 1 dt. So, and here we take the integral of e raised to minus st, that is limit a tends to infinity e raised to minus st by s, that is the integral of e raised to minus st, and we are applying the limit 0 and a. And after, when we are applying the limit, the integral limit is upper limit minus lower limit. So here upper limit is capital A, so it will be minus a s by s minus e raised to minus 0 divided by s, right? So it will be this term will be e raised to minus as, and this will be minus of minus, so it will be plus, and e raised to minus 0 will be 1, so 1 by s, so this term will be 1 by s, and this term will be e raised to minus as by s, so that is equal to 1 by s. So the Laplace transform of 1 is 1 by s. Similarly, when function f of t is equal to t, and here we apply the equation for Laplace transform 0 to infinity e raised to minus st, and here our function is f of t is t, so here we put it as t dt equal to limit a tends to infinity 0 to a e raised to minus st t dt. Okay, so this is the integral of two functions e raised to minus st and t. So what will be the integral equation of two product? It will be that means integral uv is equal to we can write it as u into integral of v minus integral of differential of u dash into integral of v. Okay. So you apply this here and we get the expressions like this, that here u is equal to e raised to minus st and v is equal to t, right? So here u is e raised to minus st, integral of v, integral of t is st, right, minus integral u dash is e raised to minus st into minus s, right? So that that will be simplified as like this. You do it as your homework, and finally we got is after simplification we get the equations will be like this: limit a tends to infinity minus e raised to minus st by s square into st plus 1, and here we apply the limit a and 0. This will be the equation, and finally we got it as 1 by s square. So the Laplace transform of function t is equal to 1 by s square minus 80, and f of t is equal to sin 80. So you do try to solve this. Any doubt in the same principle that we used in the first two questions, we'll be using here. Try to solve this. And all these equations, or that means these are the fundamental functions that we frequently used for the problems, that is f of t is equal to 1, f of t is equal to t, and f of t is equal to e raised to at, f of t is equal to sin at, f of t equal to cos at, etc. will be always used for further problems. So all you have to by heart all this Laplace transform. Next one is a problem which to determine the inverse Laplace transform of the function. Here the function is given as f of s is equal to 5 by s plus 12 by s square plus 8 by s plus 3. So we can write the inverse Fourier transform by observing this. So the first part is 5 by s. As we know, the Laplace transform of 1 is 1 by s. So we can write by observing it. So it will be 5. Then 1 by s square. If 1 by s is 1 and 1 by s square, we already find out it is t. Right. So here we can write it as Laplace transform of 1 is equal to 1 by s. Similarly, Laplace transform of t is equal to 1 by s square. These are the common function that you have to keep in mind. Similar like e raised to at. E raised to at means 1 by s minus a. Here it is Laplace transform of e raised to minus at. So that will be equal to 1 by s plus a. Okay. So here we have 5 by s plus 12 by s square plus 8 by s plus 3. So 5, 12, 8 all are the coefficients. So we can take it as a constant values. So here the function is 1 by s. The Laplace transform of 1 is 1 by s. So we can write it as inverse Laplace transform of 1 by s is 1. So 5 into 1 plus, and we know the Laplace transform of t is 1 by s square. So the inverse Laplace transform of 1 by s square will be t. So here 12 into t plus, similar like we know Laplace transform of e raised to minus at is 1 by s plus a. So Laplace transform of e raised to minus 3t will be what? 1 by s plus 3. So here we know that a Laplace transform of e raised to minus 3t is 1 by s plus 3. So inverse Laplace transform of 1 by s plus 3 is e raised to minus 3t. So 8 into e raised to minus 3t. Okay, so this will be the equation. Okay, similarly, the v of s, that is Laplace transform of v of t is v of s, that is given as 200 divided by s square plus 100. Right. So we can rearrange this s square plus 100 as s square plus 10 square. As we know, the standard Laplace transform of sin at is a by s square plus a square. So we can write by observing it, v of t is equal to 20 sin 100 t. Here we have to find out the inverse Laplace transform of a function below. That is f of s is given as s plus 6 by s square plus 3s plus 2. So here we have to do is we will factorize the denominator and then apply the partial fraction. So in order to do the factorization, here first you can take the roots. S square plus 3s plus 2 is equal to 0. So we get s is equal to minus 1 and s is equal to minus 2. So we can write split it into s plus 1 into s plus 2. For getting an easy way, here we take this 3 as the addition of this 2, 1 and 2, and here 2 as multiplication of 1 and 2. Okay, so that is the simple method to find the factors. So here we get the factors as s plus 1 and s plus 2. So we will write the equation s plus 6 by s plus 1 into s plus 2. And next we do the partial fraction. So this method is known as the partial fraction. So here we can write it as a1 by s plus 1 plus a2 by s plus 2. Next we have to find out this a1 and a2. Okay, so this a1 is equal to s plus 1 into f of s, and s is equal to minus 1. From where it is getting as this equation is, we will cross multiply this with, right, so a1 into denominator of other function, that is s plus 2, plus a2 into s plus 1 will be equal, divided by s plus 1 into s plus 2 will be equal to f of s. F of s here it will be s plus 6. So at the denominator, or s plus 1 and s plus 2 at the two sides, so it will be getting cancelled. From this, in order to make this a2, we will substitute this s is equal to minus 1. So we get equation as s plus 6 divided by s plus 2. Similarly, this equation halted, and we substitute s is equal to minus 1 here, and you will get the value as minus 1 plus 6 divided by minus 1 plus 2. So it will be 5. Okay, so similar like we can find out this a2 we got it as minus 4. So our function f of s will be 5 by s plus 1 minus 4 by s plus 2. And we know the Laplace transform of e raised to minus at is equal to what? 1 by s plus a. So from this we can write, here a is 1 and here a is 2. So we can write 5 into e raised to minus 3 minus 4 into e raised to minus 2t. Okay. So next is, here is a function, a complex function. Here the difference is, in the previous case, here there are three polynomials, x plus 1, s plus 2 and s square plus 2s plus 1. So we can do the partial fraction as a1 by s plus 1, right, a2 by s plus 2 if the denominator polynomial factors is single degree or first degree polynomial. Okay, here the difference is, here it is a quadratic equation or second degree polynomial. So in order to do that, we can do the partial fraction in this similar way. So in order to do that, we take f1 of s is equal to a1 by s plus 1. So first we take this equation only. Okay, a1 by s1 plus 1 plus a2 by s plus 2. Okay, so from that a1 and a2 in the similar method that we in the previous problem, by using equations, and we find out the constant values a1 and a2. So we get f of s is equal to 25 by s plus 1 plus 10 by s plus 2. Okay, so when we are taking the inverse f1 of t, we got it as 25 e raised to minus t minus 10 e raised to minus 2t. Okay, after that we will take it as f of s is equal to as plus b by s square plus bs plus c. So similar like here we do the partial fraction for this term only. For other term, that is second degree polynomial, we will use a partial fraction like this, that is a first order polynomial in the numerator divided by second order polynomial. Whatever the degree of the denominator polynomial, 1 degree less than this should be at the numerator, right? So that will be the residue or remainder what we have to do in the division. Okay. So here we find all this we already find out, and next you have to find out this a and b using the substitution techniques, and we get this a and b. Here what we have to do is we take the factors of this, that is 2 and 5. Or for getting b, we will substitute it as s is equal to 0, right? And getting a, you will substitute s is equal to 1. So we get A and B, and we can got the final expression as this. From this we can find out the inverse Fourier transform, sorry, inverse Laplace transform. You go through the video and try to solve these examples, and if you have any doubt we can discuss it in the conductance. And here the difference is when we are repeating poles or repeating factors in the denominator, and this will be the method to do the partial fraction. What we have to do is f of s is equal to c1 by s plus alpha square plus c2 by s plus alpha. That means in the previous problems we discussed about different factors, that is s plus 1 into s plus 2. Here s plus alpha a all square. So in that case we will factorize it by using this method. That is, first we take the constant divided by dual degree plus second constant divided by single degree. Okay, so it will be the general expressions. I think you will be more clear when we are doing the problems. Okay, here a question that f of s is equal to 60 by s into s plus 2 all square. So here it's a multiple rows, so s plus 2 all square. So in that case we will take this factor as a by s plus c1 by s plus 2 all square plus c2 by s plus 2. Okay, this method is a partial fraction, and next you have to find out this a, c1 and c2. Okay, so and C2 will be substituting when we are substituting this S is equal to 1, so we get the C2 value as 15 minus 50, and from that we can find the inverse Laplace transform. Okay, thank you.